Today we're looking at day 2 of section 3, and we're really splitting this up into 2 days. We're calling it both day 2 and day 3 just because the notes are a little bit longer. So let's go through this first page here in this video. We're looking at these identities, right? Identities are not necessarily formulas, but they are relationships. They're describing how some trig functions relate to other trig functions. So to explain why tangent of theta, or of my input, is equal to sine over cosine, it might help to go back to your unit circle and just think about some of the connections we've made previously. Let's pretend the unit circle gives us this diagram, so our radius of the circle is 1, so the hypotenuse is a length of 1. And you might remember that we've learned that the sine ratio is the opposite over the hypotenuse, right? So opposite side over the hypotenuse, you'd have y over 1. So in other words, the y coordinate is associated with sine when we have that unit circle. So then cosine is adjacent over hypotenuse, so that's the x, again, over 1. In the past, we've looked at tangent, and we've described tangent in terms of the coordinates. We said tangent was y over x. Well, if y is associated with sine and x is associated with cosine, then when we say that tangent is equal to the y coordinate over the x coordinate, we can use our trig identities and say it's then sine over cosine. Cotangent is the reciprocal of that, so it's cosine over sine. So that would be your x coordinate over your y coordinate. But in the trig identity, cosine over sine. Here we have our Pythagorean theorem represented with this right triangle, right? So you think of that as a squared plus b squared equals c squared. The c squared being the hypotenuse, which is a length of 1 when we have that unit circle. Let's call these sides x and y, so x squared plus y squared equals 1 squared. But again, if x is associated with cosine, then we have a cosine squared. If y is associated with sine, then we have a sine squared. And that's our Pythagorean identity. It's a special relationship, right? It's a way of relating cosine squared with sine squared. Now here it's set up with sine squared in front, but it's the same thing. All right, so we'll be using that in a moment. But we also want to look at some of the other relationships with some of the other trig functions, like what about secant and cosecant? What about tangent and cotangent? So we're going to take this Pythagorean identity and we're going to manipulate it. So that's what the second one is for. What we'll do is we'll say, let's see what happens if we divide both sides by something. And we're going to pick one of these so that we can see what reduces and what doesn't reduce. So let's pick sine squared. We're dividing both sides by sine squared of x. All right, so on the left-hand side, sine squared divided by sine squared is just 1. Cosine squared divided by sine squared, well, that's what we saw right up here. Cosine over sine is cotangent. So we're doing a substitution. We're taking cosine over sine out, and we're putting in its place cotangent. We're just matching the exponent, so this is a cotangent squared. 1 over sine squared. We're also going to do a substitution. Let's take this out and put something else in its place. The reciprocal identity is cosecant, and matching the exponent of 2. Now, just to make the format look the same, we want the 1 by itself. So we're going to move the cotangent squared to the other side. So we're subtracting cotangent squared from both sides. So it looks like this. And I'm going to shuffle it around so that the 1 is on the right-hand side. So we'll have a positive cosecant. We're subtracting cotangent, right? So cosecant squared of x minus cotangent squared of x equals 1. So that way it matches the same format there. So this is the relationship between cosecant squared and cotangent squared. So for the final illustration, let's see what happens when we divide both sides by cosine squared. All right, so first sine squared divided by cosine squared. We see this one up here. That's our tangent ratio. So this is tangent squared. Cosine squared divided by cosine squared is positive 1. And this is our reciprocal identity, replacing this with secant squared. And again, shuffling these around, we're going to subtract the tangent squared, moving it to the right so we get the 1 by itself. So we will end up with secant squared of x minus tangent squared of x equals 1. All right, so these are what we mean by the 3 Pythagorean identities. I'm going to skip example 7 here. Let's look at examples 8 and 9. All right, so here's example 8. use the given function value and trig identities to find the indicated trig functions. All right, so this is what what they're giving us. Cosine theta equals 1/4. There's several different ways that we can approach this, and I'm going to show you two ways in answering some of these questions. Let's start off with this one. This is the reciprocal of cosine, right? So this is an identity. This is our reciprocal identity. Secant is equal to 1 over cosine. And we already know cosine theta is 1/4, so now we do a substitution. So 1 over 1/4. And then we have to simplify that, so that's going to be 1 times the reciprocal, right? So final answer is just 4. Now when we get to sine, this is where we might not know exactly how cosine and sine relate. So I'm going to show you the old way that we used to do it from previous examples and previous days of notes, and then I'll show you the new way using the identities that we just saw up here. All right, so this is the old way. This is not using an identity, and the directions are specifically asking us to use an identity, but this is what we've done in the past. We're saying, let's take a right triangle, because a right triangle can be expressed as the ratio of two sides, and cosine is a ratio of adjacent over hypotenuse. So here's your adjacent, here's your opposite, here's your hypotenuse. So the 1 over 4 means the adjacent side is length 1, the hypotenuse is length 4, and then we use the Pythagorean Theorem to find the missing side. So b squared equals 15, and then we take the square root of both sides, and that means the missing side is root 15. Then we can answer the sine ratio is going to be the ratio of opposite over hypotenuse. So the answer will be root 15 over 4. Now, that's what we've done in the past. The challenge here is, can we do it a new way using the trig identities? Where have we seen sine and cosine? Well, we saw that right up here with the Pythagorean identity. Sine squared plus cosine squared equals 1. We're going to use this identity here. So this is the new way. So sine squared plus cosine squared equals 1. Sine is what we're trying to find. So that'll be my variable. Sine squared theta is what it is. We have a value for cosine. Cosine is 1/4. So I'm doing a substitution, plugging in the 1/4, but we have to square it, right? Because this is the square of the cosine value. So that'll give me a 1/16. We're going to subtract that from both sides. So this will be 16 sixteenths, and we're subtracting the 1/16. So sine squared theta equals 15 sixteenths. Then we want to take the square root of both sides. Don't forget your plus or minus. So sine theta is plus or minus root 15 over 4. Notice we got the same answer, except we now have this plus or minus. And that's because there's multiple quadrants on the circle, where we could just say multiple quadrants in the Cartesian coordinate plane, where we can place this triangle in such a way that we can get a sine value of that's both positive and negative. Here we just drew it in quadrant 1, right, because that's how we've typically dealt with it. But it could be placed in other quadrants, like quadrant 4, for example, and that would give us the negative. So that's the answer, plus or minus. So you can see that you get the same numerical answer either way. The old way used the Pythagorean theorem, and this is essentially based on the Pythagorean theorem. We just have sines and cosines instead of x's and y's. And we get that plus or minus here. All right, what about cotangent of theta? Let's try this one. So cotangent, we saw that is going to be cosine over sine. So let's do a substitution. So this is equal to cosine theta over sine theta. Now we're going to do another substitution, replacing the cosine theta with the given information of 1/4. And the sine theta, that's our plus or minus root 15 over 4. You can see they each have a common denominator of 4, so those 4's cancel out. So we are left with a plus or minus 1 over root 15. We have to rationalize the denominator, of course. Plus or minus root 15 over 15. So again, we have this plus or minus that kind of carried over from the previous part because we're considering that this triangle could be drawn in several different quadrants. The directions didn't say we had to limit ourselves to quadrant 1, so that's why we have this plus or minus. Lastly, this is another identity. We saw this not in today's list of identities, but in the previous section. These are called complementary cofunctions, right? So sine of 90 minus theta, we're going to replace that with its cofunction, cosine, at that same angle of input, cosine of theta. What is cosine theta? Well, that's what they gave us. That's the 1/4. So that equals 1/4. Let's look at some more uses of trig identities here in example number 9. It says, use trig identities to transform one side of the equation into the other, and be careful that you only work on only the one side, don't work on both sides. So what we're saying is this side on the left, usually it's on the left, this is the problem that you have to solve. It's the puzzle that you have to work your way through. And on the right-hand side, this is your answer. This is your solution. So you don't want to mess with the answer, because then it won't be the answer anymore. So don't be doing things to both sides of the equation. This is not an equation. It almost might be better to just pretend the answer isn't even there. All you're doing is you're just working with this expression on the left-hand side. You're trying to transform it, to manipulate it until it matches the answer. And hey, we're just giving you the answer right up front so you know what to go for. We're trying to make it look like sine theta. There's two basic types here in this problem. We want to do a substitution first to see if something might cancel out, leaving us with the answer of sine theta. In problem 2, we will not do a substitution. Here you see a binomial times a binomial. So that's a different approach altogether. We'll get to that in a moment. In number 1, we don't have a binomial times a binomial. We just have a trig function being multiplied with another trig function. So let's do a substitution. Let's take tangent out and replace it with its identity, which we saw at the top of the page. That's sine over cosine. Sine theta over cosine theta. Here, cosine theta, I'm not doing a substitution. I'm just rewriting it, putting that over 1. And you can see we have cosine theta. That cancels out with cosine theta, and all we have left is sine theta. Hey, look, we got the answer. So you keep manipulating this, you keep substituting, canceling out, you keep replacing it with identities until you match the right-hand side, and that's when you know you're done. Here's number 2. In this case, I'm not going to do a substitution because these binomials are going to be multiplied together. And when you multiply binomials, we're going to FOIL them together. So this is a very different approach. We recognize this because they're exactly the same. You start with cosecant, you finish with cotangent, but they differ by the sign in the middle. All right, let's FOIL this out. First term times first term, cosecant times cosecant is cosecant squared theta. The outside terms, negative cosecant theta times cotangent theta. The inside terms will be positive cotangent theta times cosecant theta. And lastly, you've got a negative cotangent squared. Now these two terms in the middle, even though the cosecant is in front here and the cosecant is in back here, they're really the same term because we could shuffle them around in any order. One's negative, one's positive, so they are like terms, they combine and they cancel themselves out. So you are left with cosecant squared theta and the minus cotangent squared theta. So that's the result of multiplying it. So now what? We're not doing a substitution with the individual terms. We're not going to replace cosecant. We're not going to replace cotangent. We're going to replace the entire thing. This entire thing is going to be replaced. So we're doing a substitution now. The question is, what do we substitute it with? So go back and look at your identities. We saw that cosecant squared minus cotangent squared equals 1. That's what we'll substitute it with. So all of this equals 1, and we got the answer. So that equals the 1. That's how we know we're done. We matched the right-hand side. So let's try a couple more just for some variation. Here's number 3. Again, notice you have a binomial times a binomial. This is not printed on the notes. I'm just adding it in for more examples. So we have secant minus tangent times secant plus tangent. We're claiming that equals 1. So let's FOIL this out. Secant times secant is secant squared. The outside terms, positive secant tangent. Inside terms be negative tangent secant. And then the last, negative tangent squared. Again, those middle two terms differ by a sign, so they cancel out, leaving you with the first term and the last. All right, secant squared minus tangent squared. So again, the question is, what do we replace it with? What do we do now for substitution? Go back up here. We see that we saw secant squared minus tangent squared equals 1. So that's our substitution. We replace all of that with 1. That matches the right-hand side of the problem they gave us. So we're done. Here's the fourth one. Tangent theta times cosecant theta equals secant theta. All right, now here's the challenge. I want you to try this one. It's going to be similar in approach to what we did with number 1, where you're going to start off with a substitution right away and see what cancels out. So I'll pause the video. I want you to pause the video, see if you can work it out and get the answer of secant. All right, here's the answer. Are you ready? I'll reveal it line by line. So we want to do a substitution on the left-hand side. In place of tangent, we're going to replace it with sine over cosine. But if we only do that substitution, nothing there would cancel out with the cosecant. So we also need to do a substitution on that next term. We're replacing cosecant with its reciprocal identity, 1 over sine. Now you can see sine over sine will cancel out. And that leaves you with 1 over cosine. Now we know that 1 over cosine does equal secant. That is the answer. But we're not ready to finish here because we have to keep transforming the left-hand side until it matches the right-hand side. So we're just cleaning this up a little bit. We have 1 over cosine. And yes, that equals secant. But we have to do one final substitution, right? You have to go one step farther. What does 1 over cosine result in? There it is. We took the 1 over cosine out. We put in its place the secant theta. That's the final substitution. It matches the right-hand side, and that's how you know when we're done.